Okay, here we have a system of linear ordinary differential equations. We have x1 prime is equal to a11 x1, a12 x2, and x2 prime. So this is the first derivative is equal to a21 x1 plus a22 x2. Here all aij's are coefficients, so constant coefficients. So these are constants, and we can write this system by using matrices. So we have this, so this is a 2 by 2 matrix, so this is a 2 by 1 matrix, 2 by 1 matrix. Writing the system using matrices will help us to solve the system. So today we will just study matrix algebra. Okay, let's start with the definition. So we are given a matrix A in this one. So this is an m by m matrix. So n, so here we have, so this is called the row of the matrix. So row, and we have, and this is called the column of the matrix. So this is a n by n matrix. So here we have n rows and m columns. And sometimes we can write in short as aij, jk, ajk. J denotes the row and k denotes the column of the matrix, column. And all these a11, a12, like a and m, are called entries of the matrix. And so if n is equal to m, then the matrix, we have a square matrix. A square matrix. So that is, the matrix have same number of rows and columns. Okay, let me give an example, like 2, 3, 1, minus 1, 0, 2. So this is a 2 by 3 matrix. And let's give a square matrix. So 3, 0, 1, 1, 1, 1, minus 1, 0, minus 2. So this is a 3 by 3. So we have 3 rows, 3 columns, 3 by 3 square matrix. We have 3 by 3 square matrix, and we have one more, so special matrix, I unit matrix. So in this case, we have the diagonals. So I forgot to define the diagonal. So, and all the other entries are 0. So we have 0 here. So this is a unit matrix. So here we have a11, a22, a33. So these are all equal to 1. So a n n. Okay, let's say we have n by n matrix, square matrix, and all ij is equal to 0 when I is not equal to j. So this is called the I is the I is n by n unit matrix. And okay, let me give it now the main diagonal. So whenever you have A11, A22, ANN, so this is, so we don't know what we have here, AN1, okay, this is an n by n axis. So this is the main diagonal of the matrix. Great. What about some calculations with matrices? So what we can do, we can add, subtract, and we can do whatever we want. But and we usually work with square matrices. Okay. Okay, first one is the equality. Two n by n matrices are equal if and only if corresponding entries are equal. So let's give an example. For example, if we have like A11, A12, A21, 2 by 2 matrix, and B is equal to B11, B12, B21, B22. So A is equal to B if and only if, so we have all the corresponding entries are equal, like so first row, first column must be equal to B11. A12 must be equal to B12. So A12 is equal to B12. The corresponding entries are equal. Like for example, if we have A is equal to 2 minus 1 x 3 and equal to B, B is equal to let's say y minus 5 3. If A so if A is equal to B, then we know that x must be minus 5 and y must be minus 1, right? So y must be minus 1 and x here must be equal to minus 5. Great. Okay, let's continue. The second one is addition and subtraction. So when this is so easy. Let's do it with 2 by 2 matrices, but it is true in general. So 1, 2, 8, 2, 2. If you have two matrices, so how we add them? So when we write A plus B, so we add the corresponding entries. B11, A12 plus B12, A21 plus B21, A22 plus B22. Subtraction is the similar. So if you want to subtract, so we subtract the terms. Okay, if we have, let's say, 2, 1, 0 minus 3, and B is equal to 1 minus 1, 1, 0, then we have A plus B is equal to 2 plus 1, 1 minus 1, 0 plus 1, minus 3 plus 0, and we can write 3, 0, 1, minus 3 as A plus. B. Of course, if you have A plus B is equal to B plus A. If you have A plus B plus C, you can add first A plus B and then C. So these are the properties of the matrices. And let's look at another one, scalar multiplication. Whenever you have like A, so 2A is, let's say you have, this is too easy. You multiply every entry. So A11, A12, A21. If you have 2A, or let's C times A, then you multiply each entry with constant C. So C is a constant. Let's say you have A is equal to 3 minus 1, 2 minus 3. Then we have 2A is equal to 2 times 3, 6. 2 times minus 1 minus 2, 4, minus 6. So this is 2A. Okay, the fourth one is matrix multiplication. So first of all, we can multiply only this kind of. So if you have n times n matrix and B is an m times, let's say R matrix, then we can multiply AB and we will get an n times R matrix. So the column of M must be equal to the row of B to multiply. Okay, let me write the general rule first, and then we will have lots of examples, don't worry. Okay, when we multiply A times B, so A times B, Rj is equal to, Rj entry is equal to, M is equal to from 1 to N, A, I, M, B, M, J. So what does this mean? So we multiply, so that is, we multiply, don't worry, I will do examples. So multiply each entry in the ith row of A by the corresponding the jth column of B, and then we add these products. Okay, and we get a new matrix AB is equal to, let's say, C. Don't worry, let me do example. So let's say that we have 2, 0, minus 1, 1 times. So this is a 2 by 2 matrix. So if we multiply, if we want to multiply this, so this must be a 2 by, let's say, okay, I will make up some 2 by 3 matrix. So 1, 0, minus 3, 1, 1, minus 1. And at the end, we should get, so these are we should get a 2 by 3 matrix again. So what we are going to do is we are going to multiply the first row of A with the first column of B. So here we have 2 times 1 plus 0 times, and then we add these 1 times 0, and then we write here. Okay, we continue. Okay, I will do it with color. So it is 2 times 0 plus 1. Okay, let me use another color, and then we will write the third column, first row of A, and the third column of B, and we write the third column of plus 0 times minus 1. Now we are going to write the second row of the multiplication. Now we will, okay, let's do it with blue. So minus 1 times 1 plus 1 times 1. So second row, first column, second row, second column, second row, third column. We will continue like this. Okay, I will continue it green. So we will have minus 1 times 0 plus 1 times 1. And we have the last minus 1 times minus 3 plus 1 times minus 1. And then we will do these additions. So we have 2, 0. So minus 6, minus 1 plus 1, 0. And then we have 1. Minus 1 times minus 3, 3, minus 1. So we have 2. So this is A times B is equal to C. Okay, great. And in general, so this is a remark. So in general, matrix multiplication is not commutative. So matrix multiplication is not commutative. What does this mean? So this means that when you multiply A times B, so it is not equal to B times A usually. Okay, let's do an example. Let's say we have A 2, 0, minus 1, 5 times 3 minus 1, 0, 1. Okay, let's do the multiplication. A times B. 2 times 0, minus 2. And then we have minus 3, 1 plus 5. So we have 6. And then let's multiply B times A. Oops, what did I write? 3 minus 1, 0, 1. So we have B 2, 0, minus 1, 5. So this is A 2 times 3. Okay, sometimes I also confuse, so I do like this. Uh, 6 plus 1, 7. 0 minus 5. 0 minus 1. 0 times 6. As you can see, so AB is not equal to B times A. So in general, we don't have the inequality. Okay, and sometimes we can multiply by just like what is this? 2 times 1. So this is a 2 times 1 matrix. So this is a 2 times 2 matrix. And so these are equal. We can multiply. And we will get, after the multiplication, we should get 2 times 1 matrix. So 2 plus 1, 3. 2 times 2, 4, minus 1. And then we will get 3. Okay, we have another. So this was 4, and then fifth operation or is transposition. So if you have a matrix A, let's say A11, A12, A13, A21, A22, A23. So this is just an example. Then the transpose of so we write columns of. So the A transpose is writing columns as rows. So transposition is an operation where columns where writing columns as rows. Where we write columns as rows. So what we are doing is rows as columns. Maybe that is better. So we write maybe okay row. Yeah, this is similar, but write rows as columns. Okay, we have this row, and then we write it as a column. A11, A12, A13, and the second row is going to be the second column, A22, A23. So if you have like a, let's say 1 minus 1, 0, then its transpose is going to be 1 minus 1, 0. Or let's say you have a 1, 0, 1, 5, then its transpose is going to be 1, 0. Okay, I write row as the column, and 1, 5. So it's equal to its transpose. No, it's not equal to, A is not equal to its transpose because we have 0 and 1 here. Great. And whenever you have a transpose of a transpose is itself, if you are doing some addition, then it is like this. But when you are doing multiplication and taking its transpose, it is taking B transpose times A transpose. Great, okay. Okay, let me give an exercise. So exercise, if A is 0, 1, 0, 0, and B is 1, 0, 0, 0, and C is 0, 0, 0. Then compute AB, AC, BC, and compute A plus 2B minus B plus C. And okay, hint, okay, or the answer for this one. So you should get at the end minus 1, 0, 0, 0 for this one. And the rest is similar. Okay, this is it for now.